Hello guys, I want to make a quick video. Back in the summer I was working on a F-150, Ford F-150, and had some drivability issues where my fuel trim was going positive at a higher load, and I was struggling to figure out what was the problem. So one of the tests that I've done is I was checking a fuel rail pressure. Now the Fords, they use a fuel rail pressure sensor, and some of them have only this is the sensor here when it sits on a fuel rail. This one also have a fuel rail temperature sensor as well built in, so this is a pressure and the temperature sensor. So anyway, to my surprise, when I hooked my fuel gauge on, and when I looked at the data on my scan tool, car was running, and when I was looking at the my fuel pressure on my scan tool, and when I compared it to my fuel gauge, it was almost 10 psi difference. So I was so excited. I said, well, this is the problem with my my fuel pressure sensor is skewed. It's not reporting correct pressure, and on Fords, the way it works, the PCM takes the feedback from that sensor, and then we'll send that command according to that pressure. It will send a command to fuel pump module, and the module is gonna by duty cycle will control the speed on the pump, and that's what controls the pressure. So and then I noticed something different, that this sensor has the vacuum line hooked up to it, which I didn't know what it's for. So long story short, I was going to replace the sensor, and then I realized the sensor was like $100. So I was like, I'm not sure if I should I do it right away. So actually I called Keith, and Keith explained it to me what was going on, and actually later on he sent me the link to a TST seminar.
PCM wants 40 psi. Okay, it wants 40 psi at the injector tips, not at the fuel rail. And here's what gets guys. If the spec is 40 psi and they bring up their scan tool and it says 40 on their scan tool pit, but yet then because they got a fuel system issue, and maybe they do, and they put pressure gauge on the rail, and they see 30 psi in the pressure gauge, but they see 40 psi in their scan tool. Which one do you trust? What do you conclude at that point? What would you do? If you had 30 psi on your pressure gauge and the scan tool is telling you 40 psi, what would you do? I'm sorry? Yeah, you do an average of 35. Okay, I haven't heard that one, but that's a good one. What would you do? You might want to check the accuracy of your gauge, but say you did and you verified this gauge is accurate. What are you going to do? You see 30 psi on your gauge, your scan tool's telling you 40 psi. What are you going to conclude? You think the sensor's bad, or the scan tool's lying, but okay, so maybe you think the sensor's bad, you change the sensor and you still got the same thing. What are you going to do? Maybe you're going to put a PCM in it, and if you do, you're going to be heartbroken because you're going to see the same thing. Because the PCM, that scan tool is telling you it's 40 psi here. But how does it know that? That's where the vacuum line comes in. Okay? Negative psi equals 1/2 an inch of vacuum. By that I mean, if you had an engine here around New Jersey, we're pretty much at sea level here, think. Would you say at idle, you might have an engine with 20 inches of vacuum? 18, 19, 20, something around there. Let's say it was 20 for the sake of math. It's easy. That would equate to negative 10 psi pressure in that manifold, right? If you had 30 psi in the rail, you had 9 minutes time here, you'd have 40 psi at the injector tips, correct? So the PCM, that's what the PCM wants. It wants 40 psi. But if you don't know that, you're going to think there's something wrong with that sensor or the PCM, okay?
Alright guys, well as I said, I'm going to leave the link in the description to this video. It's a really good seminar. I mean, it's but anyway, that was the that's how the computer calculates the pressure. Basically calculates the pressure at the tip of the injectors, not at the fuel rail, even though it says a fuel rail pressure sensor. So I'll just show you. Also I have a here also says this is most mechanical gauges. our reference atmospheric pressure, the fuel air pressure sensor, is referenced to a manifold pressure. In order to make a valid comparison, the engine must be off. So that's I'm gonna go here. I got everything hooked up for you guys, and you can see now my pressure is reading a 42.7 psi, and I got a 40. Too much weight here. Oh, come on now. Okay, so I have to zoom in. So, okay, so the 42.8, and I got a 40, 42.7. So anyway, on my lab scope. So now we can see that the pressure is identical now. So that's what we need to do basically. Just turn the key on, and now something else we can do. We can just drain a little bit of pressure, and see what reading gonna have. Right now we drop down to a I don't know, 17 psi, and that's what we got. There's so much glare. There you go. 17.9, 17. I mean, that's it. You guys can see it. It's pretty much dead on. I'm just gonna drop it a little bit more, and I mean, whether using gauge or pressure transducer doesn't really matter, but that's the whole point of this. You have to check this when the engine is off or engine running, but you need to pull out that vacuum gauge. So we got right now 8.8, so 9 right now. So I'm going to show you guys what happens when we start the car, and that's what got me the back in the summer. I was so excited, I said, well, this is my problem. My sensor is not reporting correct pressure. And so right now on my pressures, let's see. Okay, I'm at around 30 psi. Let's see. I go around 28. And that's pretty much the same on another F-150 as well. So there you go, 28. Now, when we look at the skin tool, it's 39, the 10 psi difference. So that's what happens to me. I didn't understand, what was going on, and the pressure sensor was $100. So I said maybe I should do some more research before I, throw the $100 in a truck. So now I'm gonna pull this gauge out, and now we can see our pressure on the skin tool it's around 40 psi, 39, 40 psi, and that's what 39. You can see this is what we got on our pressure gauge as well. So okay, that's all I want to show you guys. So if you struggle with this, basically all you gotta do is just turn the key on, connect your scan tool, look at the pressure, connect your gauge, and that's it. That's supposed to be the same. I look 38 a little bit. 39. There you go. Around 38, 39. That's what I got here, and that's what I got on my fuel gauge as well. Okay, so just gonna plug it back in. And Kate saved me big time, and he was so nice to talk to me that day, and now we're 38, 39, 40 psi, and we're at 28. So I think I did find here the voltage it needs to be. I think it's around like for 40 psi it's around 2.8 volts, and that's what you pretty much see voltage wise at the idle on these Fords. Let's see if I can find it. I had it somewhere, like a spec for. It should be here. Okay, so here's for 30 psi the voltage is 2.2, at 2.8 is for the 40. That's what you're gonna see most of the time on your voltage, on your pressure sensor at the idle. So you run 2.8, 2.9 volts. So okay, so if you need to see the spec, this is it. You can guys compare this to the pressure. So okay, that's it. I hope somebody can use this video to help itself, because I was really struggling that day trying to figure out why am I having such a differential in pressure. So okay guys, thank you so much for watching, and see you next time. Bye bye.